So we are doing the first optical instrument, which is simple microscope. What is a simple microscope? It is simply magnifying glass. And who acts as magnifying glass? Convex lens of short focal length. So, okay, simple microscope is a convex lens of short focal length. So fine, let us draw the ray diagram. See, there are two cases, and in both the cases we have to obtain the expression for magnifying power. So what is the case number 1? When the image is formed at least distance of distinct vision. So we all know what is least distance of distinct vision. For human eye it is 25 centimeter. Least distance of distinct vision. So let us see this case. We have to make a proper ray diagram. Okay. So we can label focus, optical center, focus. Now keep the object between optical center and focus. Then first ray parallel goes through focus. Second ray through optical center. Now produce them back. So produce them back. बिल्कुल straight. So this is your image that you would see. Okay, and this is the case when final image is formed at least distance of distinct vision. Now we have to do all the labeling properly. Doing proper labeling is very important. This is object's leg B, head A, B dash, A dash, this is image. Okay, now this is object's distance, it is U, and let us take it as minus X in front of the lens. This is image distance, and we will take it as per the case, it is least distance of distinct vision. So let it be D minus D, and the value is 25. So diagram is all ready for the first case. So we would use magnifying power now. Magnifying power is not magnification. It is angular magnification. Angle wise. Huh? So it is not your normal linear magnification. Height of image by height of object. No. It is magnifying power or angular magnification. So it will be equal to. See, the definition is fixed. We have to learn what is the definition. So it is the ratio of angle by image, angle formed by image at eye when considered at least distance of distinct vision. So according to the case, angle formed by image at eye when considered at least distance of distinct vision. Okay, and downward is this angle by object when considered at, this is fixed, least distance of distinct vision. So let us see. Okay, we will see it once again. By magnifying power, or angular magnification is fixed, and its definition is this. Angle formed by image where at I, when image is considered at, according to the case, I am saying according to the case, considered at least distance of distinct vision. Here is human eye. Okay, in downward it is angle formed by object at I. This is fixed. This is irrespective of the case when considered at least distance of distinct vision. You will have to write it full. So we will denote it by beta and alpha. Okay. Now for smaller angles, tangent theta is equal to theta. So this can be written as, magnifying power can be written as tangent beta by tangent alpha. Now we will see what is, we'll show where is alpha and where is beta. See, first of all, alpha is the lower name. Lower name is angle formed by object at I when object is considered at, least distance of distinct vision. This is alpha. So alpha can be shown two ways. Look here. It is some angle, right? So it is some angle. This is alpha. Formed by object. Okay, so you can show this is object. Bhaiya, this is object. When considered at least distance. So this is your least distance minus d. Or d. Distance is d. So what is tangent alpha? This is object, height of object. So tangent alpha will be height of object by base, that's perpendicular base. If you wish to draw, see, first of all use common sense. Okay, it is an angle formed by object when distance is this. That is the definition of alpha. If you wish to show it in ray diagram, then you can show it in ray diagram as well. Let us show it in ray diagram. First of all, distance has to be this. Okay, so here you will cut a height equal to object. This is object as lead distance and angle formed at I. So this is alpha. Again, it is perpendicular, which is height of object by base is this. But I would suggest you to draw separately as well, and you can show in this also. So, but keep in mind that tangent alpha we have this perpendicular by base. Now let us show beta. What is the definition of beta? It is angle formed by image where at I, when image is considered at according to the case least distance of distinct vision. So let us show beta now. Okay. If you wish, you can draw it is some angle. No, so this is some angle. Beta is angle formed by image. So this is height of image. Okay, where when we are considering it at least distance of distinct vision. So tangent beta is also ready from here, but we write beta by some other triangle. So do not write it by this. So let us show beta now in ray diagram. So distance should be least distance of distinct vision. This is image. right? So this is beta. But beta we will write from smaller triangle. Beta can be seen in big triangle, right? And in smaller triangle also, and we will write from smaller triangle. So tangent beta from smaller triangle with perpendicular, which is HO, and base is U, right? So this is what we are going to write. But tangent beta has value of height of image by D also, but that I don't require. That will not leave me to derivation. So from smaller triangle I'll write. ठीक है, this is beta and I'm writing the value from smaller triangle. This is height of object and this is U. Base is U. So we are ready with tangent alpha and tangent beta. Tangent alpha came as H naught by D. Now let us substitute, or H naught by V you can say, D you can say, or minus D you can say. Let us substitute in magnifying power tangent beta by tangent alpha. Tangent beta is, just now we have seen, it's H naught by U. And it is H naught by D. H naught cancelled. So magnifying power came as D by U. This is original formula. Important. So we all will memorize this. So now, okay, as you already know, in the diagram you can see that object distance I took as minus x, so I substitute D upon minus x. So now I'll use length formula. Using length formula, I have 1 by V minus 1 by U is equal to 1 by F. Okay, V image is formed as least distance and in front of the lens. You know from the diagram. Yes, value of V is minus D. It is in front of the lens. Value of U is minus X. Let us substitute. So we have 1 by minus D minus 1 by minus X is equal to 1 by F. Multiply with D on both sides. We will multiply with D on both sides. So D cancel, it is minus 1. Minus minus plus D by X is equal to D by F. So minus 1 will go this side. So we are ready with the value of D by X. So it is 1 plus D by F. And this we are going to substitute here. The value of D by X. So it comes as, negative sign does not matter. Okay? It is coming as 1 plus D by F. So magnifying power in first case is this. This is 25. This is focal length will be given. Remember, whenever 25 centimeter substituted, if you are substituting in place of V, it will be taken with negative sign. If it is substituted in place of D, it will be 25, a number. Because it is already being put with negative sign. Now we'll do the second case. This is the answer of first case when the image is formed at least distance. Second case is when final image is formed at infinity. Okay, so you know when is the image formed at infinity, we can make a ray diagram. We can keep the object at focus. So first ray parallel goes through focus. Second ray is through optical center. So it is not meeting any side. Okay, the image is formed at infinity and this is human eye. Okay, so image is formed at infinity. We'll take magnifying power as the ratio of, again same, angle formed by image at I. This is according to the case. When image is formed at infinity. This is the case. When image forms at infinity. And lower one is fixed. That is what I said. Angle formed by object at I when object is considered at according this is fixed at least distance. So this is again beta, this is alpha. So for smaller angles, you know this was equal to tangent beta and tangent alpha. So yes. So children, just observe the name of B as this and alpha as this. We would write it again. So this is my alpha. It is angle formed at I by object when considered at, it is fixed. For microscopes, it is fixed at least distance of distinct vision. So again, what is this angle? So we can draw an angle by object. So this is object. So this is angle formed by object. So we can label it like in a separate diagram as well. So it is an angle formed by object when considered as least distance. So this is D. This is least distance, that is 25 centimeter. So tangent alpha is ready with me as H0 by D. Separate diagram is okay. If you wish to show in same, you can show. Let us show right now. For example, you will label on your own कि this is D. Okay, so you have to draw a line equal to that of object. So this is your alpha. Even if it there no not, but you can show that alpha is this predefined. Now by image, when image is formed at infinity, so this is beta. So yes, let us show beta once again. Image is, it is the angle formed by image. Image is at infinity. So this is your beta angle at I. So beta can be written as tangent beta can be written as perpendicular by base. Base is your U. And because the image is formed at infinity, this is F. So let us look at the name of beta. It is the angle by image when image is formed at infinity according to the case. Okay, so if you wish, you can write it again. Angle formed by image at infinity. So I've shown that this is infinity, image is getting formed at infinity. This is human eye, this is beta, this was object. So perpendicular, base is your object's distance U. So I will rectify this once again. So it is perpendicular by base and U is minus F. And distance is okay, focal length, but it is in front of the lens, so it will be taken negative. Object at focus, image at infinity, that is fine, but the distance of object is F and it is in front, so it will be taken negative. So tangent beta would be written as H0 by minus F. So we are ready with tangent alpha and tangent beta, so we can substitute in magnifying power, angular magnification as tangent beta by tangent alpha. So it is H0 by minus F. What is tangent alpha? If you remember, you must have noted down. H0 by D. So it will be reciprocated, है ना? So D up, H0 down, H0 cancel. It's minus d by f. Negative you can ignore. So magnification in this case is d by f. So magnification in the case when the final image is formed at infinity, angular magnification when final image is formed at infinity is this, and magnification when final image is at least distance of distinct vision, that is first case, so that is 1 plus d by f. So you can see the difference of magnification in both the cases. Here it is 1 more and here it is 1 less. So in which case magnification is more, they ask in this case. But viewing is more comfortable here. Magnification in least distance case is more than magnification in case of infinity. But viewing is more comfortable in this case, in infinity wala case, because there is no strain in eye. But here magnification is more. So kindly prepare this topic, it is important. So at last I would like to tell you that magnification formula for microscopes downward is fixed. It is angle by object at eye when considered at least distance. This is fixed. When object is considered at least distance of distinct vision, and upper one angle by image at eye when considered at this will be according to the case. Like if it is a case of least distance, so you will write least distance. If it is a case of infinity, you will write infinity, but this is always same. So now you can prepare.